Hi, my name is Renner. I'm a senior software engineer at Active Prospect, and I'd like to welcome you to my talk, Growing Applications in Taming Complexity. Now, this talk is not about building prototypes. It's about building those applications that stick with us for the long term, like 2 to 5 years. And just out of curiosity, show of hands, how many people have worked on the same application for more than 6 months in a row? All right, well, that's a good show of hands. How about over a year? Okay, how many people have found that this type of application, if you're not careful, can become really complex and really tangled without careful planning? Good, I have too. And that's what this talk's about. And what makes an application difficult to work with? A lot of things, really. Things like maybe you've got a complex domain that you're working in, or tricky business rules. Maybe there's integrations with external services, and that's made your app difficult to test. And then the fact that it's difficult to test has maybe even led to lack of tests, and then when it's time to refactor and clean stuff up, you have nothing solid to change your app against. So there's a lot of tools out there to isolate complexity. Things like Phoenix Context and domain-driven design, which encourage breaking off different components of your app and dealing with those separately. Things like you might break out billing and break that away from emails or metrics or notifications. There's also umbrella apps that allows you to break your app apart even further. And these are all helpful tools that you can use, but how do we use them? And really, how do we take a tangled app and make it manageable? Well, we've got an example app here. It's called Crowdfundr, and it's an example web app. Just like any other app, it has user registration. And that's what we're going to follow through today, and we're going to see how this works. So user registration takes place on the create action of the user controller, and this is the canonical place to do it. And there's 3 steps. First, we create the user in the database, then we send a welcome email, and then we send a metric off to statsd. And statsd is just a metric server used for creating real-time dashboards and things like that. And we also have a mix task that does the same steps. This reads users out of a JSON file and registers them just like the other app. So it's create the user, send a welcome email, send off a metric. Now let's see a diagram of this. We have the web app reaching into 4 separate modules to actually do the user registration, and same with a mixed task. Okay, and you can see these lines getting crossed, and that's an indication that complexity is creeping in. Especially when it's time to expand what user registration is, and maybe you need to initialize the user over in a billing service, things get even a little more tangled, and you have 2 places to update. And then, if you don't tackle this complexity, as you add more and more controllers, the lines get more and more crossed, and you start getting a mess. So our goal here today is to untangle user registration and really lay a framework for the app itself to keep it maintainable, understandable, and adaptable to change. So we're not in that mess yet. We're going to start here where it's simple. There's 4 modules, and the web app and the mixed task are calling in there. And this is where we're going to end up by the end of this talk, in a nice, highly structured, flexible application. So let's get started. How do we register a user again? Well, here it is. Here it is from the command line. We call accounts.createUser to create the user in the database, user email.welcome to generate our welcome email, mailer.deliver to deliver that email, statsd.increment to send off a metric. And this is a lot. This is a lot if you're going to implement user registration in yet another place, but it's also a lot to type out in IEX. This is getting pretty tangled here. And I saw this tweet on Twitter a couple years ago that really changed my perspective on things. If your application is difficult to use from IEX, your APIs are probably wrong. I don't know who said this, but I would love to give credit to whoever said this. But they're not in the APIs. They're not talking about your HTTP APIs. They're talking about your code level APIs. What code do you have to call to actually register a user? Well, here it is. There's 4 modules, or 4 functions: accounts.createUser, user email.welcome, mailer.deliver, and statsd.increment. And where in this does it say anything about registering a user? It doesn't. It's all implied here. And we're in our app. It's called Crowdfundr. Couldn't we just say crowdfundr.registeruser? I'd say absolutely. That's what I would expect. Why don't we create a public API? So if we were to do something like that, we would go from having our web app calling into 4 separate modules, and we'd create a new layer in our application that's our public API. And then all of our user registration stuff goes through one place. And then when it's time to maybe add a new component to user registration, say reaching out to a billing service, there's one place to change it. And that's the start of making our app simpler. So we're going to refactor this. We're going to do several refactorings throughout this talk, and this is the first step. So to do this, we'll go into our user controller and grab out the user registration-related code and copy it into our Crowdfundr module. Now, we are in an umbrella app where we have the web app, which sits on top of our actual business logic Crowdfundr app. And really, I've found the best place to put a public API is your top-level module, because that's where people go to look first. So, okay, continuing on, we update our user controller and our mix task to point to this new public API, and now things are getting simpler. Now we have this new layer here. And we've made some progress. We've defined a public API in our app, and this is our starting point for cleaning this up. Now we're going to iterate, and let's improve this quality of the API. And there's really no better way to visualize your API than to generate the documentation for it. And the nice thing is, hey, here is our brand new API that we made. On the Crowdfundr, we're exposing the functionality register user. But what about all these other modules on the side? Are those fair game too? Can our web app call into our repo directly? Should our mix task call statics directly? I'd say not. We're putting a layer in here, and we don't want people circumventing that. We want everything to go through our public API so we have control over what functionality we're exposing. And so how do we indicate that some of these modules are internal and not meant to be built on top of? Well, the Elixir documentation has a guide on this, and it says basically documentation is for your users of the public API, and internal functions and stuff, that doesn't need to be documented. So what we can do to indicate if stuff's public or internal is change whether it shows up in the docs or not. So that's our second refactoring. Let's limit our docs to our public API, so that way we know what's public and what's internal. Well, to clean up the docs, there's a couple things we can do. We can use doc false and module doc false to ignore a function and a module, respectively. And then in the latest version of Xdocs, if you're working in an umbrella app, you can give it an ignore apps parameter, and that allows you to ignore like your entire web app that's never going to be part of your public API. And the cool thing here is we can, from all these modules over here, we can just limit that down to what's public, just one, and then we just end up with 2 modules, our public API and our user struct. And the reason why that's important is our public API is our contract with the outside world. This is what people build on top of, and what we don't want to break as we refactor things. And by keeping our public API small, we have a lot less to maintain, and this gives us a lot more flexibility in our implementation if we do it right. So we've made some more progress. But next up, let's look at testing. Okay, let's go back to where we were originally. And remember, the web app was calling into these modules directly, like sending an email, creating an account directly. And now we've got this public API. But if we look at our controller test here, we have the controller test on the left and the implementation over on the right. The controller test is talking about assert that an email is sent, when really there's nothing about that over in our implementation in the controller. That's because we're breaking the level, we're testing across separate layers that we shouldn't be testing across. And that's what we're going to fix. So let me show you what I mean by that. Really, we're testing the controller layer that runs up in the Crowdfundr web app. And then our goal in testing this thing should make sure that register user is called properly based on the parameters that are sent in. And then when we're testing the web layer, we also want to make sure that redirects and rendering and stuff, that works properly too. But if we test the actual implementation of what it takes to register a user here, then maybe if we change our user registration from sending an email to sending a text message, that breaks our test here. And that's not something we want. So this is my favorite type of refactoring. There's the email-related code. We can just delete that and clean it up and make our tests a lot simpler. Next up, let's look at what these tests are actually testing. The first one is covering what happens when user registration succeeds, and the second one is what happens when it fails. But what triggers these responses? What triggers these code paths that we're actually testing in our controller test? Well, right now, it's the parameters that you're sending in. And we happen to know the magic parameters that are needed to get these values to come back. But what happens if we add maybe a fraud detector that isn't totally transparent, and maybe we don't always know the parameters that are going to be needed to pass the fraud detector? Well, then maybe these parameters are not going to match up anymore with a return type. So how do we still test those code paths? Well, this is really a good place to inject a mock. And there's a great library out there called Mocks. It's by Plataformatech, and it allows you to build mock implementations perfect for scenarios like this. And what we can do is we can say, well, expect that the mock Crowdfundr receives register user, and we either return OK user or error change set to trigger those code paths. And that's great. That'll make our test work and kind of more decoupled from that public API. But how do we inject the mock? Well, my first attempt at this was, let's just have a private function that reads the mock out of the module that we want to connect to out of the environment. So we could either get Crowdfundr or mock Crowdfundr out of here. And I thought that would work, but that starts raising problems. First of all, this now returns the module at runtime instead of at compile time, so that breaks dialyzer. And dialyzer is really key here when you're swapping implementations in and out, because it makes sure that all the types match up. You don't want the implementation and the mocks to drift from what we're actually expecting here. You'd hate for the implementation to return, to be changed to return just an error atom instead of error change set, and then you don't know what's going on here, or this test doesn't fail and you ship a bug out to production. Also, then, if you follow this pattern, there's switching logic everywhere, and this just doesn't really work that well. Instead, this is ideal, but how do we inject a mock? Well, we can go look at at a diagram of our application here, and let's look specifically at that API layer, at that public API Crowdfundr layer. And in there, there's two things. There is the implementation, or the API, which is the functions that the external modules call, like those actual function definitions, crowdfundr.registerUser, and then inside that is the implementation of the logic of how you actually register a user. And what we can do is we can split the API from the implementation and make this swappable. So the Crowdfundr module will delegate to whatever the current implementation is, and this gets to be powerful. At the moment, we're just going to swap in that mock Crowdfundr implementation, and that's going to help our tests pass. But we'll cover a little more in just a minute. So this is what it looks like. Our public API becomes, we look up the current implementation and then call register user on whatever that is. And then we have a default implementation that contains the logic for registering a user. And then there's this third module. This is a behavior, and this is the secret sauce that makes it better than the previous version where we were just calling a private function. And what this is this says, here are all the functions and the parameters and the return types that you need to return to build a Crowdfundr implementation, and that keeps everything in sync. So our public API implements this behavior, and same with our default implementation, and that keeps things from drifting, and this is cool. So here it is visually, where the API delegates to the implementation, and then the behavior keeps these things in sync. Okay, so to use this, mocks is perfectly set up to use this, because you can say def mock and give it the name of the mock you want to build, and then you say what behavior you'd like to allow. Here are So it'll take the crowdfundr.impl behavior and define and allow those functions to be called on the mock crowdfunder. And then to use it, all we do is put it in the environment and we're set. Now, if we go back to our controller test, since we've put that in an environment, this crowdfundr.register user now delegates to mock crowdfunder, and it works. So we made some progress, but wait, didn't we just change code for testing? Well, yeah, we did, but there's some added benefits to this pattern, and let me show you what they are. So we've split the API from the implementation, and then we have these 4 modules down below. What we're going to do a little bit later on is we're going to refactor these 4 modules into 3 internal APIs. And now that we have internal APIs, we can split the API from the implementation. We have our swappability layer again. The implementation here, by default, connects to Postgres, and we're using Ecto. But for testing, we can swap in a mock implementation to make testing the higher layers of the application easier. But then this is where the power comes in. Maybe we've had some database outages. Maybe we need to go masterless. We can't have a single node go down and take down our application. So maybe we swap in something like React. And so all we have to do is conform to the functions that are on that internal API. And if we can implement those, we can do a React implementation. Also, if we aren't sure how we should store data, maybe try out a memory implementation to figure out, can we do key value? Do we need relational? Things like that. And this pattern is not something I made up. It's called hexagonal architecture. It was put forth by ElixirConf back in the early 2000s, and it's also known as ports and adapters. And what it is the port is where the outside world communicates with your code. And then the adapter is that swappable implementation. And this is really powerful. As you showed in the paper, this stuff gives you a lot of flexibility in your application. Where, there you go, we swap in a mock implementation, and it gives us a lot of flexibility. So we've made some more progress. Now the next thing we need to do is continue refining this public API to prevent our current implementation from leaking out and making stuff difficult to change. So if we look at our API, here's our register user function, and over here it says it's returning error change set, and there's an implementation detail. Especially if we start going to a React implementation, we can't use Ecto with it, and this would keep us from making that switch. Also, if we look in our user struct, there's a lot of Ecto implementation details in there, fields that really are only there for Ecto and not needed by the rest of our app. So that's our 4th refactoring. Now, don't get me wrong, I really like Ecto. It is a great library, and it's really good at two things. It's good at casting and validation, so when data comes into your system, converting it to the appropriate type and making sure it's valid. And then it's also really good at persistence, which is reading and writing from the database. But just as Phoenix is not your application, neither is Ecto. We need to make sure that our APIs are not tied into Ecto. Instead, what I propose is let's move Ecto around the edges to where it's good at, or to do the jobs that it's good at, and keep it out of our public API. And the first step to that is we're going to pull validation logic up. Now here's where we're at currently. We have all of our validation and casting and persistence logic down in the lower layer where in crowdfundr.account. So if an invalid request comes in, it bounces all the way down, and we get told right before it writes to the database, oh, this stuff's invalid, and it bounces it all the way back up. Okay? But let's say we swap in let's say we swap in a React implementation. Oh, okay. So if we move the public, if we move the casting and validation logic up to the top here, then we can stop invalid data in its tracks, which is really great. So then when an invalid request comes in, we validate it at the boundaries, and we don't have to worry about invalid data coming through the rest of our app and having to do data validation everywhere. And then it just bounces right back out and gets rendered out to the user. And to do this, instead of in our user controller calling the public API directly, what we can do is create a request module. And this module is really only used for this given request, and its job is I'll validate the data, or cast and validate the data. If it's valid, call the public API, and if it's not, just return error change set. And this follows the same sort of pattern as in Rails, the form object pattern. And so this is what it looks like. Really, the user, so we have an embedded schema here, and it says, hey, there's an email and password, and then in the change set, that contains our validation logic. And finally, we have a run function, and this calls the change set, and if it's okay, if the change set's valid, it calls the public API, and if not, it returns error change set. And now we have a conveniently timed feature request. So this feature request is for, hey, let's add password confirmation to the web app. Well, now that we have this, it's really easy. In fact, it's only 2 lines of code. And all we do is we put the field for the password confirmation in our embedded schema, and then the validates confirmation line down below, and we're set. We don't have to modify layers and layers of the app. We can do it all up in the web layer because we have this request module. And then we have a request that comes in, and it's got, let's see, it's got an invalid password confirmation, and it just bounces right back out. And that was much simpler to change than allowing these parameters to get all the way down toward the database. So we can get 95% of the way there with stopping invalid requests up at the top, up at the outermost layers of our app. But then there's still that thing about unique constraints, and email's already been taken. So what we want to do is we want to push the persistence-related logic down and keep that out of our APIs. So let's look at this request here. This is an email request that comes in, but this email happens to already be taken. So it returns error change set and bounces all the way back up. But the problem is if we swap in a React implementation, well, it doesn't return the same error change set. Maybe it returns a different error, and then we aren't capturing that or anything. We're just letting that bounce all the way back up, and it blows up in our web app. Instead, what we can do back at Ecto is we could, as this request comes in, we know we're going to get error change set back, but instead, we can cast it into something that's more in the domain of our app, maybe like an email already registered error. And then we let that bounce all the way back up, and we can pattern match on that and send that back up to the user, and that keeps Ecto out of our API and keeps things flexible. And then back when we're at React, it comes in, and we get that React-specific error, and we convert it into the same email already registered error and bounce it right back up. So that gives us a lot more flexibility. And here's what it looks like in that register user request. All we do is we pattern match on error, email already registered error, and then add that error to our change set. And now we are not coupled to Ecto. Our API is not coupled to Ecto. Here it is. No more Ecto in the error returns. But if we look at our user struct, there's still a lot of Ecto here. And let's clean that up. We don't need all that. Really, all we need is maybe an ID and an email. And that's all we need to pass around for a user representation in our app. So we can do that. We can create a domain-level user that is not tied directly to Ecto. And then when we when we pull users out of the database, we just cast it to the domain-level user, and that decouples things. So that way, when a register user request finally succeeds, it comes back up, it gets cast to that domain level user, we don't have Ecto coming through, and it gets bounced all the way back up. There we go, no more Ecto in our API. Okay, now the next thing we want to do is we want to organize our modules. Because I think you should be able to look at the application or at the file structure, and that should give you some insights into how the application is structured. And really here, in green, these are our public-facing modules. We have a Crowdfundr module that's a public API. We've got our user module that people can reference, and our errors module that has like our email already registered error in there. Then in blue, we have our switching logic. This allows you to switch between different implementations. But then in red, well, these are all really helper modules for the default implementation now. And so let's organize these things. Really, so if they're just helping the default implementation, let's tuck them in. Let's make them submodules of the default implementation since they're not used anywhere else. So what we can do is just tuck that in there. And now when you open up the application, you can see here's the public code, here's the switching code, and if you care actually how the app is implemented or how that API is implemented, you can go in and find these. You can look in the default info folder. Okay, made some more progress. Now the next thing we're going to do is we're going to group our submodules into internal APIs. So we have the accounts, user emailer, mailer, and statsd, and really these last three, they don't provide nice APIs. You got to use two modules to send an email, and then another module you're calling increment on to send off a metric, and that's not really nice. So what we can do is we can insert a second layer of APIs, and these are our internal APIs. We can call accounts.createUser, emails.sendWelcome, and metrics.userRegistered in our high-level code, and then these APIs can delegate to, or can call out to these helper modules where needed. And the cool thing about having an API is you can separate the API from the implementation, and then you get that swappability again. So we can, for emails, we can swap in a mock implementation to make testing easier, but then, hey, maybe we want to try out a new email client. Oh, we could maybe make a Bamboo implementation. And so that's what we're going to do. We're going to build out these internal APIs. I'm just going to show it via restructuring the file system here, but remember, we've got the green, that's the public APIs, and the red is what we're going to reorganize. We're going to follow the same sort of pattern here. And so now we have our green are our internal APIs, and they follow the same structure. Blue is switching logic, and red is our helper modules. And the cool thing is, if you look at this, this mirrors the way the application is set up in the drawings that we've seen before. And then when it's time to try out that new Bamboo client that you've been itching to build, well, there's a logical place for that to go. You just tuck it right in that spot in the directory structure, and that keeps things simple. And again, this mirrors the way, this gives us a hint in the way our application is set up. Okay, so we've made internal APIs swappable, but really, when do we add a new a layer where you can swap things? Well, there's two cases that I've found. First, when you're separating out different domains in your app, things like billing or accounts or metrics. Those domains are pretty separate, so they're a good place to put in an internal API, and then you build the higher layers of your application on top of that. Also, when there's communication with external resources, it's good to be able to test the API client or the database client separately as well. And then, as you're building business logic on top of that, you don't have to talk to the API or the database. You can just return mock responses. And things work great there. Also, if you have a case where business logic meets communication logic and they're kind of tangled together, that's a good spot to separate things out. So you can test your business logic separately from your communication logic. Okay, now let's talk about swapping performance. Now, we've been calling into the environment quite a bit, and this is surprisingly performant because it uses ets tables and read concurrency true and all sorts of things, but we don't need to make these needless calls into application.getEnv all the time. So that's what we're going to do. I've got this library called Constantizer, and this is designed specifically for this. What we've got here is we're calling defp-impl, and we're calling into the environment. And what we can do instead is we can do defconst-p-impl and with this Constantizer library, and it defines a private function just like defp does when you're compiling for dev and test, so you have that swapping ability. But then when you're compiling for production, it evaluates this thing at compile time and just inserts the module name that you want to call. And that goes from that's an order of magnitude faster, but it's still really small. Anyways, so we've improved the swapping performance, and then lastly, we want to extract these APIs into internal apps, and I'll show you why here. Now we have our default implementation for our emails internal API, and we're looking at things 5 levels deep, and that gets unwieldy. Instead, what I propose is let's pull this out into an internal app out under our umbrella, because things are already nice and structured here. So there we go. Let's see. So when I'm extracting an app, I generally like to indicate internal apps by using the project's initials. So I just say Crowdfundr, we use the initials CF, so we could do CF emails, CF metrics, CF accounts. And because we did the organization earlier, now all of our email-related code is nice and separated out, so extracting it into an app is really simple now. And then to use that app, well, all we have to do is update the mix file and point to that new CF emails app, and maybe change a few emails references in our code, and now things are nice and separated. And the other thing I like about having internal apps is sometimes I generate documentation for them, because as a developer, I'd like to know what APIs I can work with. And I know that goes against not documenting internal code, but these are basically internal APIs that you can work with as a developer. And you know, if you're building your web app, you know that these CF prefix ones are all internal, so don't touch them. So there we go. We've extracted the CF emails app. We can go ahead and extract the CF metrics app. And finally, the CF accounts app. And there we go. We have 3 apps out under our umbrella, and they all have nice internal APIs you can work with. So we've made a lot of progress in our app, and here's where we've ended up. Each one of these layers here is now swappable. We have clear boundaries and clear APIs, and it makes sense where code should go. And it's also laid the groundwork for continued application development, because, well, you can put email-related code in the emails, you can put other account-related code in the accounts app, things like that. I'd say we definitely accomplished the goal of untangling user registration to make it maintainable, understandable, and adaptable to change. So where do you go from this talk? What can you do? Well, I would definitely propose go ahead and try to create a public API for your app. Create that boundary. Start setting up boundaries in your application, and try making them swappable too. Because by making them swappable, then that helps refine your API, and you'll find out where implementation details are leaking through. And then go ahead and rinse and repeat for internal APIs. So thank you so much for your time. The code is available up here on GitHub if you want to check it out. I also want to thank Active Prospect. They're an awesome company to work for, and they sponsored me being here. My contact information is in the lower right, and thank you for your time. We can do Q&A. What's that? Yeah, we can do Q&A if people have questions.
That was a great talk. One thing that you touched on that I didn't quite understand fully, and I was hoping you could explain a little more, was improving the swapping performance. What are the performance concerns, and how did your library improve it?
Okay, so when you're calling application.getEnv all the time, when you're doing each one of these layers, any API call, you're calling application.getEnv, and that's putting a little load on the ets table and things like that. Now it's set up pretty well, but what my library does is when you're compiling for production, it will evaluate that function at runtime or at compile time, and instead of putting application.getEnv in the final compiled code, it'll just put crowdfundr.defaultimpl in there, and then you're just that lookup's already complete. You don't have to go and call application.getInv. It's just returning an atom for the module name.
You talked about moving validation up closer to the API level. How would you, or would you do that any differently if the validation required some type of database data? You know, some validation like the passwords have to match. Obviously, you can just do that right there. Mm-hmm. But what if you need to verify that some data that was entered exists somewhere in the database? You know, any thoughts on how to do that? Because I've been doing that a while, and I never can find a good, clean way to do that.
Okay, so something beyond just the uniqueness constraint.
Right, like maybe, for us, we have employees at a company, and they need to register on a website. They put in their first, last name, and employee ID. Obviously, they have to exist as employees in the database in order to register.
Right.
You know, but you want to validate that, and if they don't exist, you say, you typed in your employee ID wrong, or you're not an employee, or something.
Yeah, so absolutely. What I would do there is I create a custom validation up in that web layer, and then that would reach out to the database internal API and say, hey, given this employee ID name and whatever the other parameter was, does that exist? And if it does, great, the validation that change step function passes. Otherwise, it fails.
Okay, so you'd have that first database call to do the validation. Then if the validation passes, then it would continue on with the registration, which would involve, other database calls or whatever is involved with that.
I think so. Now, with the caveat, I'd have to look at how that affects your top level public API, and are you going to have? Is that something that's going to be? There's going to be a potential of invalid user IDs and stuff passed into that public API. That it's kind of an it depends answer, but that's where I'd start and see how it works.
Okay, thank you.
Okay, I have kind of a follow-up question. So you talked about the register user request and putting ecto at both the top and the bottom, right? And so where would you define that register user request struct? Would that be defined in the kind of ecto module at the bottom, or is it defined in the web layer itself? And yeah.
Right. So the way I wrote are you talking about? Okay, there was a struct up at the request struct. That's up in the web layer, and if I can, oh cool, I have my slides back. Let me pull that code up here. No. Let's see. Okay, well anyways, so the way where I defined that struct was I just, the register user request struct was underneath, it was just a submodule of the user controller, because that's the only place it's ever going to be used. So that's not on the public API, it's just kind of an implementation detail of the user controller. And I know that's not like a pattern that a lot of people use, but really I've treated submodules as that's an implementation detail of the parent module.
So is there any concern about that getting out of sync with what's required to actually register a user?
Well, that's where you have the public API, and you're testing to make sure that your user request calls the public API correctly with the correct parameters. So if you add new parameters to public API, you're going to have to update your user request struct anyways.
Okay, thank you.
Oh, okay. So in your early example where you refactored out a test for an email on a controller test, I totally get it, very valid. I just have sometimes had issues where side effects like that, you want to do a request and make sure at the end of that something like an email does fire off. I don't like that because it is coupling, but sometimes it's been hard to validate those side effects. So I mean, if you encounter issues like that, what do you do when you really want to make sure that like a full scenario is tested out?
Well, I mean, there is the option of you can absolutely build out an integration test if that's what you want to do. I'd also test my public API layer once I have those internal APIs, I would make sure that the public API calls the correct emails related function on the internal API, so I could test that boundary. But yeah, you can absolutely, there's nothing in here that prevents you from doing integration tests if you want to do that.
No more questions?
So at the end there, you pulled up some of the internal implementation details into their own apps. What are the trade-offs for doing that?
For actually like documenting these things?
Is that the primary concern? Is that they seem to be sort of first-class citizens of the application, so you'd expect them to be documented, or?
So I guess you have your public API that you build the web app on top of, but 95% of my application development work is not working on that public API. It's working at the lower layers of the app. So I want to, when I need to interface with the emails component of my system, I want to know what's available. What can I call? Or maybe I want to interface with my data store. Like, is there a function for this? Well, I can go look there quickly and see what my public APIs are instead of having to dive through app after app after app.
Thank you.
Thank you.
Yep. Cool. Thank you.